Hi, I'm Jelly and I will be discussing about functions. What is a function? A function relates an input to an output. It is like a machine that has an input and an output, and the output is related somehow to the input. F of x is the classic way of writing a function. There are always three main parts in a function: the input, the relationship, and the output. For example, we have an input of 0 and the relationship is multiply by 2, then the output will be 0. Why? Simply because 0 multiplying by 2 is equal to 0. Another example is we have an input of 1. The relationship is multiply by 2, so 1 times 2, we will get an output of 2. Same as 7 times 2, we will get an output of 14. And 10 times 2, we will get an output of 20. For an input of 50, what is the output? Simply multiply the 50 as an input by 2 and we will get an output of 100. 50 times 2 is equivalent to 100. There are some examples of a function. S squared is a function. X cubed plus 1 is also a function. Sine, cosine, and tangent are functions used in trigonometry. But we are not going to look at the specific functions. Instead, we will look at the general idea of a function. First, it is useful to give a function a name. The most common name is f, but we can have other names like G or even marmalade if we want. But let's use f. We say f of x equals x squared. What goes into the function is put inside parentheses after the name of the function. So f of x shows us the function is called f, and x goes in. And we usually see what the function does with the input. F of x is equal to x squared shows us the function f takes x and squares it. For example, with function of x is equals to x squared, let's say we have an input of 4. 4 becomes an output of 16. In fact, we can write f of 4 is equal to 16. The x is just a placeholder. Don't get too concerned about x. It is just there to show us where the input goes and what happens to it. It could be anything. So this function, for example, f of x is equals to 1 minus x plus x squared is the same function as f of q is equal to 1 minus q plus q squared. H of a is equal to 1 minus a plus a squared. W of theta is equal to 1 minus theta plus theta squared. The variable x, q, a, and etc. is just there so we know where to put the values. If we have an input of 2, let's say f of 2 is equal to 1 minus 2 plus 2 squared, we will get an answer of 3. Sometimes a function has no name and we see something like y is equal to x squared, but there is still an input of x, a relationship squaring the x, and an output of y. At the top, we said that a function was like a machine, but the function doesn't really have belts or cogs or any moving parts, and it doesn't actually destroy what put into it. A function relates an input to an output, saying f of 4 is equal to 16. It's like saying 4 is somehow related to 16. Like for example, this tree grows 20 centimeter every year, so the height of tree is related to its age using the function h, or we call the height. Let's say the age of the tree is 10 years, so we will find the height by putting 10 years as an input. So age of 10 is equal to 10 times 20. So we will get the height of 200 centimeter. A function is special because it has special rules. It must work for every possible input value, and it has only one relationship for each input value. This can be said in one definition. A formal definition of a function relates each element of a set with exactly one element of another set, possibly the same set. There are two important things. First is each element means that every element in X is related to some element in Y. We say that the function covers X relates every element of it, but some elements of Y might not be related to at all, which is fine. Second, exactly one, meaning that a function is single valued. It will not give back two or more results for the same input. So for example, f of 2 is equal to 7 or 9 is not right. Note that 1 to many is not allowed, but many to 1 is allowed. 1 to many is not okay in a function, but many to 1 is okay in a function. When a relationship does not follow those two rules, then it is not a function. It is still a relationship, but just not a function. For example, in this example, as you can see, it is clearly shows that it is a function because every element in X is related to Y. No element in X has two or more relationships, so it follows the rules. Notice how both 4 and -4 relate to 16, which is allowed. In the second example, we can see that it is obviously not a function. It is a relationship, but it is not a function because we can see that the value of 3 in X has no relation in Y, and the value of 4 in X has no relation in Y. Lastly, the value of 5 is related to more than one value in Y. But the fact that 6 in Y has no relationship does not matter. Using vertical line tests, we will identify if it is a function or not. On a graph, the idea of single valued means that no vertical line ever crosses more than one value. If it crosses more than once, it is still a valid curve but is not a function. In this example, it shows that it is not a function because a vertical line crosses two values. Functions also work on sets with infinitely many elements. We have here example y is equal to x cubed. The input set x is all real numbers. The output set y is also all the real numbers. We can show all the values, so here are just a few examples. You can see in this table with the values of x and the values of y are all real numbers. In our examples in the previous slide, the set X is called the domain. The set Y is called the codomain, and the set of elements that get pointed to in Y, or the actual values produced by the function, is called the range. And here is another way to think about functions. Write the input and output of a function as an ordered pair, such as 4 and 16. They are called order pairs because the input always comes first and the output is the second. Open and close parenthesis, there is an input and an output. So it looks like x and f of x. For this example, we have 4 and 16 means that the function takes in 4 and gives out 16. A function can then be defined as a set of ordered pairs. For example, we have here an ordered pair of 2 and 4, 3 and 5, and 7 and 3 is function that says 2 is related to 4, 3 is related to 5, and 7 is related to 3. Also, notice that the domain is 2, 3, and 7, which are the input values. And the range is 4, 5, and 3, which are the output values. But the function has to be single value. So we also say if it contains A and B and A and C, then B must equal to Z, which is just a way of saying that an input of A cannot produce two different results. Example, the pair ordered pair of 2 and 4 and 2 and 5 and 7 and 3 is not a function because 2 is related to 4 and 2 related to 5 means that 2 could be related to 4 or 5. In other words, it is not a function because it is not single valued. We can graph them because they are also coordinates. So a set of coordinates is also a function if they follow the rules above. That is, we called a benefit of ordered pairs. A function can be in pieces, which means we can create functions that behave differently depending on the input value. We have here, for example, a function with two pieces. As you can see in the graph, when x is less than 0, it gives 5. When x is 0 or more, it gives x squared. To summarize everything about the functions, we therefore conclude that a function relates inputs to outputs. A function takes elements from a set, which is the domain, and relates them to elements in a set, which is the codomain. All the outputs, which are the actual values related to, are together called the range. A function is a special type of relation where every element in the domain is included and any input produces only one input, which is not this or dot. An input and its matching output are together called an ordered pair. So a function can also be seen as a set of ordered pairs. Thank you for watching. I hope you learned something about functions.